We are in part 1, and that means we talk about things, we discuss things. And so we talk about bump, displacement, and normal in this episode. And these are all 3 different ways of changing the appearance of an object without modeling it manually, for example. And we do this all the time inside of the material, but we do it with a texture most of the time. Of course, we can use shaders, but this is a series about photography, and so images are the key main element here, even if I go with normal to something completely different, just to explain it, which I will show you here right now when we go here to this texture. And this texture is produced in a plugin, which gives me the option to produce as well in 3D the normal, the bump, and other channels. And I will show you here the normal map so you get an idea what I'm talking about, because this is a typical normal map. It could be completely green instead of this bluish here, and that has several reasons, but it has always RGB in it because it needs these 3 colors to express something. What it is all about, I will tell you in a sec, but first of all, we go here now to this little guy here. And this sphere was before a primitive, which I have called up from this menu. And this is now a polygon object, which means I have set it up before a little bit lower in segments to 16, went then to this icon here, or press the C key to make it editable, and then I went to the polygon mode here. After pressing Ctrl or Command A, I get here this result. And you might think, I don't have here these white little pins on it. These are normals, and the normals are very important for the calculation of the surface. You have to go here in this menu and configure all to get the normals, the tinted ones, and then you have these little guys. They have no influence to your final result in terms of rendering, but they are there in the calculation, and they create finally what makes this whole sphere smooth instead of just facet-like. So let's take them away, because now you know how it works, and we want to explain and explore, of course, the normals here. And the normals is something that is very important. First of all, it is created out of the points, which are the main element in every scene when we talk about polygon modeling. And these 4 points here in this case create finally this polygon. This polygon has a face, and this face is facing to a certain direction, and this is the normal direction. And it can go also in the opposite direction. Even some applications have both directions. Cinema 4D works with this one direction, and so you can identify on which side something comes. Anyway, this direction here is so important because we can finally decide how smooth an object is based on these normals. They are always 1 time per polygon here, and when I go here with this direction and would calculate now here 1 point after the next with the same direction, we would get here this hard edge. To avoid this, we have the Phong tag, and Phong is a second name of a developer, and he had the idea to say, when we have here a direction and we have from this polygon a direction, then we can say we start with this direction when we want to render maybe these pixels here on this line, and we want to end up, of course, with this direction. So each pixel between should go then more and more from one direction to the next direction, and that means we get it smooth. And we don't want to have that, of course, always smooth. When we have, for example, a cube, then we want to have a sharp edge, for example, or something like that, a bevel. And then we want to have something that has a definition of these edges. Either way, not smooth and round. And so we can say the angle here from this polygon to this polygon, or from this normal to this normal, shouldn't have a greater value than whatever we put into the Phong. And there's of course another option that we say this edge is Phong broken, and then it will not be smoothed along when we say so. And this idea finally led to bump mapping. And bump mapping by itself is the idea that we can map a gray map on this object, a texture, and the gray map has everything between black and white. It mustn't have black, it mustn't have white, but it's possible. And when we have black or white, the normal direction stays the same. Sounds weird. But any change when we have, for example, here a texture that is here completely black and here completely white, and then it goes in a gradient more and more into white, then the normal, when I have here my surface, the normal that is looking in this direction and the normal that is looking in this direction and has this texture here underneath, the normal would go then a little bit faster to this direction and then goes back to the normal direction, the standard direction. So there is a change in the direction based on the change in the gradient. If that would be here just black and white with a very hard edge, no gray value, no anti-aliasing in it, just black and white, the normal would go straight, straight, straight. And if there is some irritation, maybe one little tiny pixel would go in this direction, maybe a tenth of a pixel, so there could be a flickering, some noisy characteristic, and then it goes back to straight, 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 always parallel lines. And so just a black and white texture wouldn't do the trick. It should be always a little bit blurry here, a little bit less exact. And so in that way we can finally go with the direction of these normals into the game, and we can fine-tune these directions with a gray map. The change the direction. If it stays all the time in the same way, it stays in the same direction as the polygon object would give already. The side effect is, of course, it is only a calculation. It has no effect on these points here. It doesn't change the average direction of the polygon. And that means we keep these edges here very sharp. There's no rounding, no smoothing. This sphere wouldn't be round, perfect at all at any time. But the whole surface here would look very smooth. Displacement mapping means that we take the points of this object here and we move these points up and down. And up and down means, of course, relatively here to this direction. And the idea is similar to the bump map, but has a completely different result. Because when we move this point here, for example, up and down, the contour here, the outline, would change dramatically, for example. And the idea is, and I take here purposely green because I want to show then something else. When I go here with just black, for example, and then I go more and more into gray, and then the right side would be here just white, maybe here just a little bit. And we have here these points. Let's use blue for a moment for these points here to make the difference. So when we have here 3 points, we have the edges, we have a point, we have the edges, and these are the edges here. Then, based on the settings that we have, for example, in black and white, we can say black doesn't move a thing. 50% gray moves it 50% of the value that I have given, how it should be moved, and white would give then 100%. It's like multiplying. Black is 0, white is 1. So 1 means 1 time the 100% of what we have given. And we can say also it could be intensity. And I use here, for example, let's say that color for a moment. Intensity means we have the 50% gray here. It stays, no change at all. And with black it goes down, or the opposite direction based on positive or negative values that we have given, and white goes 50% up of the value that we have given. So it's maybe easier to adjust when we want to go in, when we want to go out, and the overall shape stays the same then. And as I said, I have purposely here used already green, because we could have also a red and green map. And it starts full with red and goes then here into nearly nothing. And it starts full with green here, goes to half green and then to nearly nothing. And the idea here is then that when it is at 50% here, it stays the same. And red is then, based on the settings that we have done, just going out, and green is just going in, or vice versa, whatever the settings have done. So we can move each and every point here in that direction, and that changes, of course, the whole shape. And it's very, very massive when we change this, because it's not just a fake. When objects intersect for each other, then we will see that the contour where they intersect will change. With bump map, that wouldn't be the case. So, and then there's something that is a little bit more complicated, and that is sub-polygon displacement. And sub-polygon displacement is an idea that we create new polygons based on the change that we have in that texture. That can be black and white, that can be red and green, or, as I haven't mentioned it, RG and B, all three colors for the movements in this coordinate system. The SPD, or the sub-polygon displacement, means that we introduce new points, and these new points finally have, of course, edges and create new polygons inside of that existing polygon. And the simple answer is, when I take here blue again, when I subdivide it only by one, that means one time in this direction, one time in this direction. So first I had one polygon, and I move 4 points around. Then I subdivide it by 1, that means 2 by 2, that is 4. When I subdivided it by 2, that means I subdivide each little thing once more, that is 4 by 4, that is 16. And then, and I take another color, otherwise it's just blue, I subdivide 3 times, that means each one again. And then I get here exactly 8 by 8, which is 64. And you can see it goes dramatically up in terms of density. And to limit that a little bit, we have here, of course, only the need when we have a lot of change in the texture, then we get a lot of new polygons here. That's the beauty. So we don't have to model all of that, but it goes rapidly higher, and that's, of course, CPU intensive. And that closes the part of the displacement. Have a look into the manual, because I want to give you here only an idea. The more you know about this, the more you know how to create finally the textures for it, because this is something we can't really photograph. I want to do it, but it's tricky, it's not really precise. And not really precise and tricky gives me here the bridge to the next part. So we have then not only here 4 by 4 points, we would have on each of these crossings new points. And even if the result is remarkable and breathtaking sometimes, when you see how much a tiny little noise pattern, for example, can create, then we hesitate maybe to use bump map again. But the truth is, bump and displacement together is a very, very powerful couple, because bump should be used maybe for tiny little areas, displacement more for the a little bit bigger ones, and bump map not too small, because if I have it too small, I get a noisy character in the object when I animate something. So whatever the displacement isn't giving me, maybe I can go away from the 64 toward to 16 and increase with bump the details on the surface, so I have a look like a 64 subdivision here, which is only 3, and the 16 is finally calculated, but the bump map adds nearly nothing to the render time, but I get nearly the same result. It's always a question of trial and error, because on the end the render time is maybe enormous when you go just higher and higher, maybe even to 4. And that closes the displacement here for this part. And now we want to take a look what we can do to get maybe a similar idea of such a surface without moving points around, just again simulation, but that would be maybe the bump on adrenaline. And that would be then called the normal map. And as we have explained already, the normals here are a direction. And before I go deeper into that theme, let's put this all away here. When we talk about normal mapping, then we have something that works similar to the bump map, but it's way more advanced. In bump map we had only a simulation of a change of these normals here, and if there is nothing, we have not even really a change of this, black and white for example. And this little pin here gives a direction in space, and I have to draw here another axis system just like that, and I think you are familiar with this one here. And we have different ways for normal maps, so bear with me when I go here just step by step. When we have these axes here, we can say that, let's put this vector here in gray, that would be here the normal. It's always 1 unit long, mathematical 1. And when I think about that, this here would be a flat area, then I could go here just in the y direction down, and I would find a point here. And this point is expressed in x and c. The same would happen if I project this point here just to this plane. And then I have a value that is expressed in y and c again. That should be here. Okay, put it away. That should go here directly to this point. If that doesn't fit, then I have done something wrong. And the same is of course true, but not needed here at the moment. When we have y and x, we can project this then to this place, and it should go here then down and so on to this side here. So we have a cube here, and the diagonal is then, or a rhombus, and the diagonal is then here exactly the vector. When we see here this value in green, this value in blue, and this value in red, then we can think also that the x, y, and c value could be expressed in r, g, and b. And that is exactly the case with the normal direction. The whole object here, the whole surface, instead of calculating all the time every tiny direction here, could be expressed with r, g, and b. And that stored into a texture, like the black and white or green and red texture that we had from the bump map. Just a standard texture, R, G, and B, and all the calculation goes away. And that was the idea, to use this predominantly for games, because games need real-time rendering, everything needs to be done. And when we know there's no change in the surface, then we can store this. With animation it becomes a little bit more critical when we use fixed values here. But sometimes this is a real time saver, and these RGB values are then stored back, give here this point, and this here is always considered the origin point, the 0 point. And so we can go with RGB values one time around, and we get always our directions here for every pixel that we have set here with the texture. And then we go here back, just like that, and then we can see here already what we have. We have R, G, and B values for all directions, and there are different systems of course available. One takes the normal direction based on the surface, on the polygon. Some takes it from the object and calculate from there the R, G, and B values. And some say, I take the whole world. The world system is absolute, and the object, I don't care. I want to have the absolute values. So there is of course a discussion, and that is why you find in Cinema 4D some little checkboxes to change this. Flip out Y and Z, for example, or Y and Z. And this here is of course so powerful that I want to show you that more in detail. And I show you here the equivalent. That is the bump map. And you can see here we have everything in black and white. There's less information in it and there's less power in it. And so we can say we can't get the same amount of detail out of the bump map than we get out of the normal map. But the bump map by itself is easily paintable, as I will show you as well. First of all, I have here already a scene that I would like to discuss a little bit later, but the Macbeth chart is here to guarantee that I have the right light, not only a white balance in it, also everything that I need to create a fairly good profile for this situation. That means the camera light and everything else, to get something that looks really as I have seen it outside. Of course, my monitor is calibrated. Without that, there's no quality possible, of course. So the whole chain of color is given. And what I have here is just a plane with an image. And you can see that looks rather flat. What I have done here is, of course, that I have set up a scene and I have created here, of course, something for the displacement. But before we go there, bump is the first term here, and I use here just noise. And the noise should give me here now something that looks a little bit different. I put this here up very high and I render this here, and then I get here dark areas. And these dark areas here are based on the light situation that I have here. 75% is way over the top, just to make the point here. 20% is normally the default point. That means what you get when you open the material and you see there's only a little bit. And control click here, open windows, so you can see that in a better way. Here, these dark areas, these are shadows based on the calculation that the noise gives here. So when I take here a different noise pattern, I could find something that comes more or closer to the stone pattern here. Close this here, and I can't see here very well anything. I can see it here on this area. I see here some stuff going on, and here on the street you see the noise pattern here. This gives kind of a relation, and the relation is not so much that we have a nice texture. It creates a relation to the light source here, because we get a tiny little shadow and a tiny little highlight on the place. And on a stone it is nearly invisible because it looks so natural here. When I switch this off and I render this again, it's much smoother and you don't see here these little bumps and humps. And this is bump mapping, very simple. And as I said, we have here the strengths and we can take this up or down very easily, no problem. Okay, so bump is that. Displacement is a complete different chapter, and for that I go here to my layer and I click on it and go here to open window, and I show you what I have done here, because this is, as I said more than often, not that simple to create. And this texture here is half the way done in Photoshop with a little bit curve manipulation, and the rest is just painted here. So I got here some black areas that is all painted, and I blurred it, put it on top of that. We will go there. And these values here finally give me here now the option to say, please go, and this is intensity. This is not centered, as I have explained it. Intensity means the black gives nothing and white gives 24 centimeters when the strength is to 100%. So these things belong together. This is the sub polygon displacement SPD, and as I have said, 3 gives already 64 times the amount of polygons. And when I switch this on, you see this preview here. I open this one again so you can see that, and you can see here already the stones go really out of that texture. When I switch this off, everything is flat again. And have a look here to this area here. When I switch on the bump map, I get maybe some little dents here and so, but the roundish area here is totally unaffected. Okay, so I can have micro details here, and with the displacement on, I get the little dents, so I can cover some shortcomings if I choose a smaller displacement setting here. And I get here even these nice little edges here. And you see here, we could have even more subdivision. What is that all about? For what is it good? Because that would work maybe perhaps. But the beauty is, in the moment I render this with the displacement, and I have overdone here the displacement, these stones, they are much too big now here in terms of elevation from the displacement. But you can see here I create new light inside of that area. And so it looks much more natural. And you see here as well 2 different light sets. To save a little bit time, I have prepared this here. And so we go here to this guy, and we can see here, this is one light situation, this is another one. No bump map here, just displacement. And we can change now the light with some highlight effects. You can see that maybe here on this stone much better. I go here for a moment to 100% and move this here around. So I can go now here with A and B, obviously not. Have to go down a little bit. So, and now I can go up here. Sorry for the delay. Back to this corner here, and now you can see here maybe this stone, and when I move, the shadow changes and the light direction here, the highlight changes. I have in each case 2 lights, one fill light and one main light. And so you can see we get here also in the color chart something completely different. One time a little bit warm, one time a little bit coldish reddish, but it's up to you what you think. And of course this would be here then the normal map. I'll show you how we can create this, but it's very nice to see here the difference. And to make that more visible, I have created here a layer, and I have put a gradient here, and that means I take half of the stones away in terms of displacement, and then I render this here again, and you will see there is a sharp line here where it's cut it off. And there you can make your own decision what is looking better or what is looking worse. I have overdone it here, so these shadows looks horrible to my eye, but perhaps someone likes this way. But you see here where it stops, we have these shadows from that line. It's a straight line that goes here more and more. When I go to my layers, switch the situation here to a different light situation, then we see the shadows go in the other direction. Just like that. And that means we can relight a situation. We don't need to model all of that, which is a huge advantage. And the painting of this area here, that was maybe 30 minutes for this huge area here, very detailed. And there's certainly someone who likes to do the Photoshop work, and you see here the border very nicely. So what I want to do here now is, of course, how can I create a normal map from that? That's pretty simple. We go here to the plane, we go to text, we go to Cinema 4D text to back texture, and in the attributes manager we go then to normal maps. We get here a new field, so we can flip X, Y, Z, swap out Y and Z, and so on. I exclude here any settings because this is not a series about texture baking, but when you click here, you get immediately here that hard line. You see here, I had it before off. This is the Macbeth chart here, very tiny. And here we see the bump map is even also in it, and the displacement. When you have this map in a good resolution, you can put this into your channel here, into the normal channel here, just like that. If you get some third-party material, you maybe have to swap you out, change the method, whatever, and then you can switch off bump and displacement, and you have only here the normal map. And after that, I want to show you, of course, the little example that I had from my Photoshop plugin. I know this is more the theoretical part, but just to go here one time along, I take here plane, just leave it where it is, and I go here to new material, go into my folder, I leave this material here for a moment alone, go to the normal, switch this on, go here to load material, go into my folder, normal tile, and I don't put it into my folder because I have no folder, and I have to select here, of course, from my multi-layered file, everything normal, and off we go. And that gives me here already the first change, and I drag this here on it, and you might immediately see we get here something. And of course I want to have here in the content browser maybe something. Let's drag an HDRI here inside of that, and we go with the sky, place this on top, and then we get hopefully some reflections here, and we have of course to switch this on. So now we get here something, and it will be a little bit milky because the color is here on, but you see here immediately we get all these reflections, and the artifacts are here because the anti-aliasing is to geometry, and that takes more time to render, but then the jagginess goes away, and we can go even closer into it. It has some potential here. The texture is not really large, but you see here how smooth all of that is. And of course I could go also with less reflection, and we could go with a material here in maybe something like this, and render this again, and it shows up very nicely. And in the moment I switch off the normal map, I get just that. Just flat. It's all here in the normal channel, and I have shown you how we can use this, and I want to show you of course where I got this from. And so I go here to Photoshop and F and filter forge, and version 4 is already in beta, and I guess when you see this tutorial 4 is already in work. Cancel. And this is here just one filter, and it's done by someone who is called Kradapilya. I hope I pronounce this right, sorry if I don't. And we get here in the render maps all these options here, normal map for example, and it starts immediately to go into the work of that. All of these filters that I have here were free, and of course I have also done my own little stuff here. And that sums it up already. Just a little hint. I will go to this plugin a little bit more in detail later on in the production part. But you see already we have tons of options. Sometimes it's maybe a good idea to create a normal map. Sometimes you are just fine with bump, and sometimes you are just better off with a displacement map. These all are more or less artificial maps. I thought I have to introduce you to that concept, especially when we go here to Cinema 4D and to my stone tiles displacement, where we had all these stones in it, where I painted exactly this. And you might get an idea that the black ones was always what is pretty much flat here, and then the more white it becomes, the more prominent it sticks out. That sums it up for this part, and see you in the next one. Thanks for listening. Have fun with it. Bye bye.